Right, so we're going to look at inverse normal distribution. So we've been looking at how to find the probability under a normal distribution with some constraints attached. Inverse normal is obviously the opposite. We're going to be given the probability, and we want to find what situation gives that probability. So the trick here is that there are three types of probabilities we can be asked. We've got the probability where something is greater than a number. We've got the probability where something is smaller than a number. The last one our calculator can do for us is to give us an even distribution on either side. So probability from negative k to between negative k and k, whatever that number happens to be. Alright, so the pictures for these look like this. The probability of x being greater than k would be this picture here, where k is somewhere. Alright, we don't know what that something is, but we do know that this part of the diagram has a probability. Alright, that probability is called the area, and it will always be a decimal between what and what? What does it have to be between because it's a probability? Right, 0 and 1. Okay, so that's the picture for that one. If we've got this one, less than k, so it could be k still over here, and we've only got this little bit here, all right, or between negative k and k. Now those have to be evenly spaced, which I didn't say on my other video, but that's right. So if this is the mean, we've got negative k here and k over here. So half the probability on either side of the mean. Okay? So first of all, we're going to look at it with a standardized normal. So this means that we've been given the mean equals 0 and the standard deviation equals 1. Okay? And in our picture, we've been asked to find out what x is. Well, it's standardized, so we don't have x, we have z. Yeah, z greater than 0.6, let's say. So we draw our picture. Here's 0.6 greater than, in here there is, oh, we don't know that's 0.6. In here we know, try that again, greater than 0.6. Right, here's 0. Half on either side. We need to know where on this bottom line z will be, so that 0.6 out of the 1 under this curve, will be on that side of it. So which side of 0 is it going to be on? Yeah, it's going to be over here because that's 0.5, right? So we need a z greater than 0.6. Z has got to be greater than 0.6. No, not that either. The probability that z is greater than something has got to be 0.6. Okay, so 0.5, we need a number on here that if it's greater than it, this side of it, it's going to be 0.6. So that's 0.5, we need an extra 0.1. So we need our k to be here. That's 0.1, this is 0.5. You see that? All right, so remembering that half on either side of the mean. Okay, so that's what we're trying to find. We're trying to find that k. Now, our calculator luckily does this for us, as long as we've drawn our picture and can see which of these situations we've got. Because on this side, we're talking about our right-hand side. This one is obviously a left hand side. This one is classed as the centre. Right, so those are our three scenarios, and we have buttons on our calculator, luckily, to do this for us. You can do these without a calculator, but because we have them, we're doing it with. So, when we go to our calculator, we used to go to normal, distributions, normal, and the second one in. We're now going to go to the third one. So, we're going to go distribution, normal, and instead of going 1, 2, 3 to the C and D one, we're going to go to this one which says INVN or something like that. Alright, and when that comes up, it's got a whole list of things you have to fill in again. We're going to fill them in for this particular case. It always asks for which side are you looking for first. So there's three things at the bottom, right, left and centre. We need to do, in this case, right. So we want right. So that's F2. Then we want the area, which is 0.6. Right, then the standard deviation, which is 1. Remember, always writing down all of these things. And the mean, which is 0. And away we go. That value there gives us negative 0.7063. I'll try entering it again. Okay, I didn't change the area, my bad. Somehow or other it came up as 0.7. Alright, good. Trying it again, we get negative 0.2553533. Okay. Right, happy with that? Okay, now as we talked about, we don't have that many standardised distributions. So we're going to look at a non-standardised one and what the difference might mean. So we've got a scenario, let's go with, what did we do yesterday? Bars. If a factory needs to have 80% of bars less than some weight. Where the mean is 5 grams and SD is 2.3 grams, what will that weight be? Alright, so if a factory has got to have this because that's what it says in its quota, we need to find out what will the weight be that 80% of the bars will be less than. So, looking at the picture, we've got a mean of 75, 80% less than something. So this is 0.5. Over here we've got 0.3 somewhere. This is our K. Alright? So we need that side of it. So, we go to our calculator and we write it down as the probability of X being less than K has to be equal to what? And that is what? 0.8. Remembering that it needs to be a decimal. 0.8. Right? 80 over 100. Right, next step, we go to our calculator and we enter all the things we know. So, which tail do we have? I don't understand what that is 0.5. Okay, so this is half the picture. So to be less than it, we have half on either side. Therefore, we have to go 30% into that side to get our 80%. Right? So 80% is all we're really interested in. But we're looking at what does our picture look like. So it is a left-hand tail. So we must change that. We've got 0.8 as our area. We've got a standard deviation of 2.3 and a mean of 75. And it says that it must be, K must be equal to 76.94 grams. So that value there is 76.94, which they probably round up to 77 in the real world. But we've got to make sure that we give enough accuracy to show we didn't guess it, we got it on our calculator. All right? Any questions?